Welcome to today's lesson over linear equations in two variables. Today we will begin by discussing a linear equation. As written here, linear equations will graph as a straight line. Now you can also identify a linear equation from the variables in the equation. In other words, look at example 1. So long as your variables have an exponent of 1 on them, then it is considered linear, and if you graphed it, it would be a straight line. In example 2, you have x to the power of 2. Immediately that causes this to not be linear, and when you graphed it, it would not be a straight line. In example 3, you have the square root of x. Really, that could be rewritten as x to the exponent of 1/2, which is not going to be linear. So you can tell from the equation if it's linear or not, which would also define whether it would graph as a straight line. Now, in the next topic, it asks me to solve the equation for y. In other words, it wants me to rewrite the equation so it says y equals. Let's look at an example. Let's look at number 2 here and solve it so it says y equals. I would need to subtract 7x off of each side of this equation. It would then say 2y equals 8 minus 7x, but I'm going to write the x term first, which would be a negative 7x plus 8. I would then need to divide off the 2, and then my equation would say y equals a negative 7/2 x plus 4. It is written as they asked, solved for y, or so the equation says y equals. We do this quite frequently. Now let's move down to topic 2. We are asked to graph a line. Let's look at number 6 because it has a fraction in it. When I graph a line, we typically draw a table. We make up x values and then solve for y. Now when I make up an x value, it's going to be multiplied times a negative 2/3. So if I want to eliminate the fraction, I will multiply by a number like 3 or a multiple of 3 to eliminate that fraction. 0 is always handy and it will eliminate the fraction. 3 will eliminate the fraction, and so will negative 3. Let's look at this algebraically. To find the value for y, replacing x with a negative 3, my 3's would then reduce out as 1, leaving a negative 1 behind. So then I would have a negative 2 times negative 1, or 2 plus 4. This y value, matching the negative 3 for x, would be 6. If I use an x value of 0, I do know that anything times 0 equals 0, so this would be 0 plus 4, or my y value would be 4. The last number I chose for my x value was a 3, and when I substitute the 3 into the equation, once again my 3's will divide out as a 1, leaving behind no fraction, negative 2 plus 4, which is a positive 2. I now have 3 ordered pairs to graph, the first being negative 3, positive 6, the second 0, 4, and the third 3, 2. Now these 3 points should line up into a straight line because this is a linear graph. And when I graph this line, I should put arrows on the end because the line continues in both directions. Now to the next page, let's look at topic 3. Find the slope of the line given 2 points. When asked for the slope, especially given 2 points, they want you to use the slope formula, which you have probably heard of, which is y2 minus y1 over x2 minus x1. Looking at number 9, let's just return to the first point as being point 1, and the second point we'll call it point 2. My goal is to take the second y value minus the first y value as the numerator of this fraction, and the bottom, the denominator, will be x2 minus x1, which will be 3 minus a negative 2. Now you're subtracting a negative number in that denominator. The numerator is just 5, but 3 minus a negative 2 is 3 plus 2, which is also 5. Therefore, you would have a result of 1 being the value of your slope. Now let's scroll down to the next set. Topic 4 again is asking for the slope, but this time you're given an equation. To do this, again you want your equation to say y equals. So when we convert the equation to y equals, it turns out to be y equaling an mx plus b if you write the x variable first. When you do that, the coefficient or the number in front of x will be your slope. I'm going to look at number 13. Now, I'm going to distribute the 2 first. I'm going to move this over to the side where I have a little more room. So this will be 2x plus 6y equaling 8. Now, to solve it for y, I need to subtract 2x off of each side of this equation. It will then say 6y equals, and I'm going to put the x variable first, so the negative 2x plus 8. Now I must divide everything by 6 in order for it to say y equals. So this will be y equals a negative 1/3 x plus 4/3. Now the question was, what is slope? Now remember, listed up here, I said when you write your equation as y equals, the coefficient of x, or that m, will be your slope. In other words, the slope is going to be negative 1/3. Now remember, slope is a number. There is no x variable attached to slope. It is just the number negative 1/3. While I'm here, I also want to take note that this number on the end was going to be your y-intercept, meaning the point 0 4/3 will also be a point on that line when you graph it. Now let's move to the next page. Now we are graphing. Let's look at number 16. Now, to graph this, I'm going to solve it for y, which actually the directions did say. Graph the line using the slope and y-intercept. So if I go back to this form of the equation y equaling mx plus b, it is called the slope-intercept form of the line because it gives me the slope and the y-intercept. My goal is to write number 16 so it says y equals, which means I can pull the slope and the y-intercept very quickly from the equation. So to get it to say y equals, I'm going to subtract 3x off of each side. We should be getting pretty good at this now. Writing the x term first on the right side of the equation, then dividing everything by 2 so that it does just say y equals. This would be y equaling a negative 3/2 x plus 4. So now this is in what they refer to as slope-intercept form. And the reason they call it that is because we can get the slope immediately from the equation as the coefficient of x, and we can get the y-intercept, which is the point 0, 4. Now, when I graph this, I'm going to graph the y-intercept first, which is the point 0, 4. Then I'm going to use the slope to get an additional point. Now, slope, if you remember, is defined as the rise over the run. Well, that means negative 3 means I'm going to go down 3 because it's negative. And the positive 2, because it is positive, means I'm going to go right 2. So I go to my graphed point, my y-intercept, and from that point I go down 1, 2, 3, and I go right 1, 2 to create another point. Once I have 2 points, that's enough to draw a line. Now I don't need to forget to put the arrows on the ends because the line continues. Now let's move to the next page. Here we are connecting to college algebra material. Number 1 says to write this equation in slope y-intercept form, which we're pretty good at now. That means be certain you rewrite it as y equals, so then you can pull the slope and y-intercept from the equation. Number 2 is a little different. Here it's asking me to actually write the equation. Well, to write the equation, we're going to go back to this handy y equaling mx plus b to write the equation. Well, to do this, I need two things which they give me. I need the slope and I need a point. They've given both of these to me quite conveniently. The slope and a point. If I write y equaling mx plus b, the first thing I'm going to do is go ahead and replace the m, or my slope, with the number 3. At this point, I almost have the equation, so I'm going to put a dashed line around it. All I need to do is find this number on the end, this b value, which is my y-intercept. To do that, I'm going to use the remaining information of the point 3, negative 8, replacing the y with the negative 8 value, and the x with the value of 3. When I've done that, the only thing remaining in the equation is b. Now it says negative 8 equals 9 plus b, and if I subtract that 9 off of each side, I get a negative 17 equaling b. So now my equation is y equaling 3x minus 17. The next question here is asking for the slope of the secant line. Just in case you don't know what the secant line is, this red line is the secant line. And there are 2 points on your red line, here and here, and you will find the slope of that line using the formula of y2 minus y1 over x2 minus x1. Number 4 here I'd like to focus on. They ask for the average rate of change. Well, the average rate of change is pretty simply the slope. So, to find the slope, we're going to use a special method here. Again, the y2 minus y1 over x2 minus x1. This is in function notation, and if you're more comfortable with even equation instead of function notation, just replace that f of x with y. Now, what is interesting here is they've given you an interval. So, as an interval, both of these are x values. So, if we need 2 points to find the slope, one of my points will have an x value of negative 5, and my other point will have an x value of negative 2. So I need to find the y values that go with those x values and then apply the slope formula. Well, this is going to be y equaling x squared. My x is a negative 5 plus 2. Or in other words, y equals 25 plus 2, or y equals 27. So my first point is a negative 5, 27. My second point has an x value of negative 2, so this is negative 2 squared plus 2, which is a 4 plus 2, which is 6. So this is the point negative 2, 6. I take these 2 points and apply it to the slope formula. So my slope is y2 minus y1 over x2 minus x1. Again, I'm subtracting a negative number, so be very careful here. This will be a negative 21 over a negative 2 plus 5, which is 3, resulting in a negative 7. So your slope is negative 7.